Hello, geometry students. This is Mr. Heron. Welcome back to 6.2. I hope 6.1 went well for you and that you're ready to kind of press on. And Pythagorean theorem is something that will show up again and again. So the faster that you can get good with Pythagorean theorem, the more helpful it's going to be throughout all of Geometry B. I'm just going to forewarn you now. So now we move on to a concept called geometric mean. And if mean looks familiar to you in a math sense, I don't blame you. Most of you would be familiar with an arithmetic mean, okay, and maybe more commonly known as an average. Okay, so arithmetic mean was when you had, you had like a whole bunch of values and you had to add them all up and divide by how many there were. Okay, and that gave you your average. Okay, that gave you your mean. That was arithmetic mean. Okay, so that was arithmetic. You're adding, and then dividing. Geometric mean fits into a different category, so it gets a little bit more complicated. So we'll talk about that, and then we'll talk about kind of how that applies to right triangles. Okay, kind of how that matches up. Okay, so just kind of be aware that we're going to kind of combine these two things together. So now this is a little bit of review from the end of Geometry A. Okay, so proportion, we compare two equal ratios. Okay, so this is A over X and then X over B. Okay, so we call the X's, these are called the means, and the other ones are called extremes. Okay, so now when the means of a proportion are the same number, the number is called the geometric mean of the extremes. Okay, so you can kind of ignore this this box down here for right now. So essentially what this means is that algebraically I would take x squared, which is a times b. So to solve, so x is just going to be the square root of a times b, okay, where a and b are numbers. All right, and most of the time they'll be integers. Okay, so basically what this is called mean extremes, but we use mean twice. Okay, don't get too hung up on this if you're not 100% sure. Algebraically, this is kind of the punchline. This is kind of what you want to be able to do here. Okay, but you want to understand what that represents. So a geometric mean, okay, so when they ask for a geometric mean, what you're looking for is realizing that you're just going to multiply the two together and then take the square root. Okay, so that is going to be the square root of 80. Okay, so what this becomes then is I can split this into, actually I can split this into 16 and 5. So simplified, this would be 4 square root of 5. All right, if I was following that simplification stuff we were doing before, that's what it would be. So now if I actually took the square root of 80, got a decimal answer, it would be 8.94. That's what I'm doing. Okay, if I want to be very picky, be very technical, setting this up looks like this: 9 over x equals x over 4. So then using ratios and proportions, this is what I'm going to do. X squared equals 9 times 4. So if I square root both sides, x will be the square root of 36, which will just be 6. Okay, that's all I'm doing. Okay, that's what I'm looking for. All right, so now we're going to kind of apply this idea. Okay, so now An altitude. Altitude is a word, is a vocabulary word. Of course, it's a word that we use in geometry within a triangle. Okay, it has to follow two simple ideas. You have to start at a vertex, okay, and you have to be perpendicular to the opposite side. Okay, perpendicular to the opposite side. So I mean, if you think about it like this, okay, like this is the ground. Okay, you're up in the air. You know, that's considered your altitude. You know, how far is it straight down? Okay, that's one way to think about it. All right, how far is it straight down? Okay, so and technically, yes. I mean, I could rotate the triangle. I could draw a vertex from or an altitude from this vertex or this vertex, but we don't have to get crazy here. We don't have to draw all three. I'm just trying to kind of get you used to this idea. This is called an altitude. Okay, that's your altitude. And it's important to note that that is a right angle. Okay, and I'll show you why in just a moment. Okay. When you draw an altitude, you do a couple things. Okay, so let's start. So if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original and to each other. Remember, similar, especially when it's spelled correctly, apologies for that. Similar means something very, very specific in geometry, okay? Similar means angles are congruent, sides are in proportion. Sides are in proportion. So if I consider what they're saying, and this is going to be very, very helpful. Okay, so let's just say I draw my altitude, and we'll call that point Z. Okay, when I do this, I have actually created two additional triangles in addition to my original triangle. Okay, so let me just kind of draw this out. Okay, so I've dropped my altitude there. So now I've got a triangle that if I sketch it, okay, so that becomes Z, A, C. Okay, and that represents this triangle. Okay, all I did was flip it around. It has a hypotenuse of B. And I could easily, you know, this whole thing, this whole length down here is C. I might just say, you know what, this is going to be X, and this length will be Y. Okay, so this length would be X, and we'll call this height. Okay, we'll call this height, so that'll be H. Okay, I've also got a second triangle, and that's going to be this one here. Okay, so now this one's going to look a little weird because I'm going to kind of twist it and rotate it. I've got a hypotenuse of A. Okay, my bottom side is going to be H. This is going to be Y. Okay, so this is going to be Z, C, B. Okay, so I actually kind of rotate this one up, and then I also kind of flip it. Okay, so that's kind of what that looks like. And then my final triangle is my original triangle. So I just kind of take this whole thing and rotate it, and I'll draw that down here. You have your original triangle where my hypotenuse is C, my right triangle is C, this becomes B, that becomes A, this becomes A. So this is the original. Okay, this is the one I started with. This is just, all I did was just kind of draw it. Just kind of rotate it. So now what you need to realize is that I've got 1, 2, 3 triangles, and they're all similar. They're all similar. So if I say triangle CZA, that'll be similar to BZC, and then BZC is similar to BCA, and finally CZA will be similar to BCA. So these are all similar to each other, okay? And what's important about that is that my sides are all going to be in proportion. Okay, they're all going to follow, they're all going to follow, this rule, okay? This rule of side over side, side over side. Maybe that's wrong letters to use because they're in the triangle, but that's kind of the idea. Okay. So this is kind of a shortcut, all right? This is called the altitude theorem. And here's kind of what this says. The altitude drawn to the hypotenuse of the right triangle separates the hypotenuse into two segments. So that makes sense. So if I draw this altitude, call it H, I cut my far side into two pieces, X and Y. The length of this altitude is the geometric mean between the two segments. So what does that mean? That means X over H is equal to H over Y. Okay, put another way, H is going to be equal to X times Y, take the square root. All right, my altitude ends up being a geometric mean between the opposite sides. Okay, notice, I don't care about B, I don't care about A, I don't use those. Okay, I'm only looking at my hypotenuse. That's it. Okay, it's a nice idea to kind of wrap your head around. So, now let's take a look here. Okay, so we have a right triangle, we have an altitude. So what I want to do is we're trying to figure out X, Y, and Z. I want to sketch kind of my triangles and see if I can at least get them to look similar. They are similar. Just to kind of understand. So I'm going to take short triangle here, okay? So that would be L, that would be M, that would be J. Okay, that makes that X, that makes that Y, that makes that 5. So now if I just kind of rotate that top one a little bit, okay, that's 20. That will be Z. That will be X. So this is M. This would be L, and this would be K. And then if I take the big original and I just kind of rotate it that way, just kind of flip it, that would be K. This would be L. This would be J. So now here, my hypotenuse becomes 25. Okay, I take this entire side. This would be Z, and the bottom would just be Y. Okay, so now they want to figure out X, Y, and Z. So now I'm looking at these three triangles, and I'm trying to see, okay, what kind of sides match up? What kind of relationships am I talking about? Well, one that kind of sticks out to me is okay, I've got X here, and I've got 20 here. I've got 5 here, and I've got X here. Okay, and if you notice, this is exactly the same as this idea that, you know what? These two got split into 20 and 5. Remember, altitude, okay, is going to be the geometric mean between 20 and 5. So X is going to be the square root of 20 times 5. Okay, so the X is going to be the square root of 100. So X is just going to be 10. Okay, that was just that idea that we were talking about on the other side. And this, kind of the way that I have these written up, says that in a different way. It's the same thing, just said in a different way. Okay, so now I know that X is 10. So I can erase this a little bit. So I know that this is 10 and this is 10. So now if I'm going to figure out Y, a couple different ways I can do that. Number one, it's still a right triangle. All right, still a right triangle. So I could easily do 10 squared plus 5 squared equals Y squared. That would be fine. I can do that. I can do that down here as well for Z. Okay, I could do 20 squared plus 10 squared, not 0 squared, equals z squared. Hey, and that works, and if it works, run with it, okay? It doesn't have to be something overly complicated. If you see a way that works and you're comfortable with it, go with it. So let's see, that would be 125 equals y squared. So square root of 125, y is going to equal 11.18. So this would become 400 plus 100. So square root of 500. So z would equal 22.36. So we've got x, we've got y, we've got z, we've answered all the questions. And a big component here, a big piece was recognizing, wait, this is my altitude, this is my altitude, and it's going to be the geometric mean between 20 and 5. Okay. Figure out the values of C, D, and E, even though the problem gives us X, Y, and Z. So obviously they mean X, Y, and Z. So again, I'm looking at a couple different strategies here. Number one, I'm looking at, you know what, they give me this altitude. We're going to assume it's a right triangle. We're going to assume that is the right triangle. So remember, 12 is going to be equal to 9 times x square root. Okay, it's going to be equal to that geometric mean. So now how do I solve that? Well, I would square both sides. So 144 equals 9x. Divide by 9, divide by 9. So x is going to equal 16. Pretty easy, 16. So now how can I figure out z? Well, z is over here. That's nothing more than a right triangle with z as the hypotenuse. Okay, I can do a squared plus b squared equals c squared. Okay, don't overthink it. Don't get complicated. So it's some work later. 225 equals z squared. You might recognize that as 15. Okay, so z is 15. I'm going to do the same thing with y, because once I figured out that x is 16, again, it's just a Pythagorean theorem problem. I told you Pythagorean theorem would show up a lot. So 16 squared, 256, 144. So when you add those together, it's 400. Square root, y equals 20. All right, so we have x, we have y, we have z, problem solved. Okay, so I can kind of start to get clever. Okay, so now, utilizing this idea again, realizing that this is my altitude. So this would be, if I wanted to be really, really technical, I could say, okay, it's 24 over w plus 4 equals w plus 4 over 6. Okay, if you wanted to say, you know what, w plus 4 equals the square root of 24 times 6, you wouldn't technically be wrong. Okay, so let's look at this. So you would have w plus 4 squared equals 24 times 6, which is going to be 144. So multiplying that out, that would be w squared plus 8x plus 16 equals 144. So that would be w squared plus 8x minus 128 equals 0. So I just subtract 144. And I'm doing this algebraically. Okay, I'm doing this algebraically. Just as an example, just because it's good to see it that way. So I got to do some factoring. What multiplies to negative 128 but adds up to positive 8? And you might have seen this. So I start playing around with some of the factors. So that becomes plus 16 and negative 8 would get me that. So it becomes W plus 16 and W minus 8. So solve. So W either equals negative 16 or W equals 8. This answer makes no sense because you can't have a negative number. You know, negative 16 plus 4 is negative 12. Can't do that. Okay, that's not possible. So my answer has to be 8. Okay, now this is kind of the long extended version. Over here, what W plus 4 equals square root of 144. All right, so W plus 4 equals positive 12. So subtract 4, W will equal 8. Same idea. But one thing you will need to know is that when you take the square root of something, technically plus or minus 12 would work, but we just took the positive because we knew our answer had to be positive. Okay. So now you go and do the 6-2 assignment and do the 6-2 quizzes to 100%. Then go on to 6-3. Okay.